Hi, welcome back. I'm Nisha. In the previous video, we discussed about functions with the default arguments. So you all know what is user-defined function and about arguments or parameters, right? Yeah. So if any doubt is there, please go through my video. I put that link in the description box. Because this video is the continuation of that user-defined function. So today we are going to talk the two different methods of passing arguments. So what is argument? Argument means the value passing from the calling place to the function definition. Okay, so let us start. What are the different methods of passing arguments? So just we can recall what is arguments or parameters in detail. So arguments or parameters are the values passed from the calling function to the call function. That we already know, the values passing from the call function to the call function. That is called arguments or parameters, right? But there are two different names for that arguments. So what are the names? Just see. The constants or variables or expressions used in function call are known as actual arguments or actual parameters. The constants, variables or expressions used in the function call. At the calling time, we are passing the values. Directly we can pass the values 10 or 20 like that we can pass it, or variables x or y we can use it, or expression like x plus y we can pass it. So these are the actual one. So we can call it as actual parameters or actual arguments. Okay, so see the next point. The variables used in function definition as arguments are known as formal arguments. The variables used in the function header of the definition. So that is called formal arguments. So these are the two names for arguments or parameters. So the first one is actual parameters and the next is formal parameters. Actual parameters are the parameters used at the calling time, and formal arguments means or formal parameters means the variables used in the function definition at the header. Okay, that is formal arguments. Just see the example. This is a function calling sum x comma y. So here x and y values we are passing to the sum function. This is called calling step. Okay. Now see the definition here. Void sum, then in bracket int a comma int b. So these are the arguments we are using in sum function. Okay, so which one is formal and which one is actual one? See here. So here x value at the calling time, that x value will pass to a, right? And same like y value will pass to b. Okay, so which one is actual one here and formal? The variables used in the function definition as arguments are known as formal arguments. See, the variables used in function definition is called. Now the function definition is this one, and the variables used int a and b are the variables used for that sum function in brackets. So this is called formal arguments. And see this point, constants, variables or expressions used in the function call. So this is function call. Here we used variables x and y. So these are what? Actual parameters, or we can say actual arguments. Understood now? So these are arguments or parameters. Okay, actual parameters or formal parameters. Two different names are there for the arguments. Actual one is the constants, variables or expressions used in the function call. This is function call. Okay, so these are the values we are passing. So these are called actual arguments. And in the definition, we are using variables. See, the variables used in the function definition as arguments. As arguments means the brackets. on the header, we are putting the variables. So these arguments are known as formal arguments. Clear now? Okay. So methods of calling functions. The function callings methods can be classified as call by value method and call by reference method. There are two different methods, call by value method and call by reference method. In C++, by default, call by value method is using for the passing of arguments. Okay, so what is the difference? Let's see. So here the first one is call by value method, or we can say pass by value method. So what is pass by value method? There are three important points I put. In this method, the value contained in the actual argument is passed to the formal argument. So here value is passing from actual to the formal one. Okay, now see the second point. If the formal argument is modified within the function, we are changing that formal arguments from the function. The change is not reflected in the actual argument at the calling place. Understood that sentence? The formal argument is modified within the function. That will not reflect in the actual arguments. If any changes we are making in the formal one, it will not affect the actual one. That is the main important point of call by value. Understood? So what is happening when you are passing? See the third point. Exclusive memory allocation is required for formal arguments. If it is called by value method, exclusive memory allocation. Exclusive memory allocation means separate memory allocation is required for the formal arguments. So we are creating a copy, separate copy for the formal one. So two different locations are there. So we are changing in the formal location. It will not reflect in the actual location. Clear now? This is called by value method. We are just copying the value to another location and we are changing that value from that location only. It will not affect in the actual one. This is called by value method. Clear? Okay, here I'll show you one C++ program for swapping two numbers. That is a question. Okay, so by using call by value method. See the statements. First, hash include iostream.h. Then this is the prototype, function prototype. So void swap is the function and two integer arguments we are passing. Okay, now main, and what are the statements in main? See, int x is equal to 20 and y is equal to 10. So two variables are there, we declared it with and we initialized with 20 and 10. And see out before swap. So before swap itself we can print it, the values in x and y. Okay, so x is equal to x and y is equal to y. We'll get the values on the monitor before swap itself. Now swap, we are calling the function swap for swapping these values. Okay, so after the swap also we can check it what is the value in x and y. So see out after swap, see out x is equal to x and y is equal to y. So we'll get before swap result and after swap result. Clear? So this is main. Now we can check what is the function definition, swap function. See, void swap, bracket int m comma int n. So these are the two arguments we are using in function definition. This is called formal arguments and this is actual arguments. Okay. Now, so what is swap actually? Swap means we want to exchange the values of m and n. So how we can exchange this? We need a separate variable, temporary variable for swapping. Okay, so here we used int temp as the variable, and in temp the value of m we are copying, and m is equal to n means we are copying the n value to m, then n equal to temp means we are copying the value of temp to n. Now we exchange the values of m and n. Clear? Okay. Now we can check what is happening here when you are using call by value method. Okay, see here, x and y are the two variables. So x is 20 and y is 10. and see the memory allocations here. Memory address 1000 is the address of X, okay, and 2000 is the address of Y. Now just for example I put it here. Now M and N, two variables are there for in void swap. Now we can check what is there in M and N. See, M and N, these are formal one. See, M is in 3000 location, N is in 4000 location. So call by value, when you are using call by value method, here these two actual parameters we are passing to the formal one. Values of actual one we are passing to the formal one. So formal is in different location. See, it is in 3000 location and N is in 4000 location. And temp also we created, is it? Yeah, temp also we created, that is also an additional one for swapping. Now we can check when you are calling the swap function what is happening there. So swap, we are passing the values X and Y to M and N. X will copy to M and Y will copy to N, is it? So X will, the value of X 20 will copy to M now, and 10 will copy to N. See, we copied in M and N. So these are different locations. See the location here. This is the memory address here. Okay, 3000 and 4000 and X and Y in 1000 and 2000. Now the statement int temp is equal to M. So temp is empty now. Okay, temp is equal to M. So temp is copying the value of M. So temp is 20 now. Now M is equal to N. We are copying the value of N to M. So 10 we are moving to copying to M. So M is changed. Now N is equal to temp. N is equal to temp. Now M and N are 10. Now next we want to get the 20 in where N. So N is equal to temp means we will get 20 in N. Now swapping over. Is it? Yeah, first M was 20 and N with 10 and we swapped it with 10 and 20 now. But see the values in X and Y, that is still 20 and 10. So that is called by value. If you are modifying the values in the formal one, it will not affect, will not reflect in the actual one. That is called by value method. Now what will be the output? See this, before swap and after swap. Before swap, X is 20, Y is 10. After swap also we are printing the same X and Y. See, X and Y is not reflected. The M and N only changed. X and Y is in the same condition itself. So X is equal to 20, Y is equal to 10 itself. This is called by value method. Got it? We are copying the value of actual to the formal one, that is in another location. Clear? We can do whatever changes we wanted in the formal one. Clear? Okay. So now we can check what is called by reference method, okay, or pass by reference. See the points here. When an argument is passed by reference, see, call by reference, they are passed by reference. So the reference of the actual argument is passed to the function. Reference of the actual argument is passed to the function. When it's called by value method, value of the actual argument is passed to the formal one. So here reference address, reference means address, memory address of that variable is passed to the formal one. That is the difference of call by value and call by reference. So when you are passing the reference, what is happening there? Just see, reference variables are used as formal parameters. So what is reference variable? A reference variable is an alias name of another variable. What is alias name? That means we are giving a substitute name for the actual one. Okay, so the formal parameters are the substitute name for the actual parameters. That is reference variable. Clear? So how we can make it into a substitute name? See, ampersand sign, and, or we can say and or ampersand. So this sign is placed in between the data type and the variable in the function header. So where we'll use the formal parameters, the function definition header part, is it? So when you're using the formal parameters, use that sign, which sign? Ampersand sign, in between the data type and the variable. So now the computer will take it as a reference variable. That means we are giving a substitute name for the actual one. Clear? Now the next point. So when you are using a reference style, actual parameters will be variables only. So we can't pass it as a constant one. We can't pass it as an expression style. We can pass only with variables. That is understood, is it? Because we are passing the address. If we are passing direct value means how we will get the address? So that is wrong. So when you are passing the actual one, we need to pass it as variables. Clear? Now see the next point. The changes made in the formal arguments do reflect in the actual arguments. When you are using call by reference style, if any change is there in the formal one, it will automatically affect the actual one. How? You see this? Reference variables will not be allocated memory exclusively like other variables. What is the meaning? If it is a reference variable, it will not create any separate memory allocations. So, the memory of the actual arguments is shared by formal argument. Understood now? If it is a reference one, the memory of actual argument is shared by formal arguments. There is no separate location for the formal one. Understood? So these are called by reference style. Understood now? So we are passing it by reference method. So when you are passing reference method means we need to create the formal parameters as reference variables. How we can create that it as a reference variable? Just use ampersand sign in between the data type and the variable and the function header part. Okay, then the main important point is when you are passing, the actual parameters must be variables. Okay, so when you are using reference one, the changes, whatever you made it in the formal one, it will reflect in the actual one. Understood? Why it is happening like that? Because memory of actual argument is shared by formal one. There is no separate location for the formal one. They are sharing the same location. Clear? Now we can check the C++ program. Okay. Now we can check one example for call by reference method. Same program itself swapping two numbers. Okay. Now see the statements. Hash include iostream.h header file. Then the prototype void swap and in bracket int ampersand comma int ampersand bracket close semicolon. Here at the declaration time itself, function declaration time itself, we want to specify that the formals are reference variables. Okay, so we need to add that simple with the data type. Clear? Okay, now main with two variables declaration, x is equal to 20 and y is equal to 10. We initialized it with two values. Now before swap, we are printing the values before swap. X is equal to x value and y is equal to y value. Then we are calling the swap function with the value x and y. Now after swap, we can check the result of x and y. So see out x is equal to x and y is equal to y. So this is main. Now we can check the swap function. Okay. See void swap int and ampersand m comma int ampersand n. So this is formal variables here, formal parameters here. So this is called reference variables. Reference variables means we are giving a substitute name or we can say alias name. Okay, different name for x and y. So here we used m and n. For x we are using m as a name and for y n. Clear? Now, normal swap statement, we want to exchange the values. So, we need to use a temporary variable. So, temp is equal to m, then m is equal to n is equal to temp. So, we exchange the values. Now, we can check with the example how it work in the memory. Okay, see, x and y are the two variables here, 20 and 10. See the locations, 1000 and 2000. Clear? Now, next is we are calling the swap function. Swap function. So at the calling time itself, for the same location, we are passing the reference. So for the same location, we are given the name as m and n. See, for x is m and y as n. The same locations we shared. The formal is shared with actual one. See? Understood now? Now, int temp is equal to m. So temp is separate one. Temp is equal to m means the value of m. The value of m means the value of x itself. We are copying to temp now. Then m is equal to n. M is equal to n. So we are copying the value of n to m. So same like y to x. See the change? So we copy it to m. Now n is equal to temp. So the value of m is here now in temp. Is it? So this value we want to get it in y or n here. So we copy it. Now see the same memory location. We just give a name as m and n. That is called by reference. We are passing the reference to m and n here. So the same locations shared by m and n. So the changes made in the formal one is reflected in original one, the actual one. Okay, now we can check the output screen. See this? So before swap, x is 20 and y is 10. Before swap, 20 and 10. Then after swap, what is the result in x and y now? See, it is swapped 10 and 20. X is 10 and y is 20. How it changed? Because changed it with reference variable. So reference variable means with the same memory allocation itself, we are sharing with m and n. The name is m and n. For x we are giving as m and for y n. Understood now? So this is called by reference. Got it? Okay. So I hope you all understood the concept of call by value method and call by reference method. So in call by value, we are passing the value of the actual parameter to the formal one. So separate memory allocation is created for the formal one. So whatever changes we made in the formal, it will not affect in the actual one. When you're using reference one, so the formal is automatically act like a reference variable. That means we are giving a substitute name for that actual one. So the same memory allocation is shared by formal and the actual one. So whatever changes we made by formal variables, it will reflect in the actual one. So that is called by reference. Okay. So see you all in the next video with a new topic, recursive function. So till then, take care. Bye.